Good evening, students. This is the session 8 from the playlist of alternating current, and today is the Q&A session from the topic of LCR circuit. So in the previous session we have discussed about the LCR circuit, and we have tried to understand the phase relationship between this oscillating potential difference and the oscillating current which is flowing in this circuit. So in the previous session we have also derived the equation for the impedance of the LCR circuit, and impedance is basically the total resistance offered by the elements which are present in the LCR circuit to the flow of the current. So here I have taken one question which is based on what we have studied in the previous session, that is in the session number 7, and the question here is that this is a circuit diagram which consists of an this resistor, a capacitor, and an inductor, and this combination is connected to an AC source whose voltage is given by V is equal to 20 cos omega t, and the angular frequency is 2000 radians per second. So we have to find the amplitude of the current. So in this case we will be first of all finding the impedance of this LCR circuit. So the formula for the impedance for the LCR circuit, as we have discussed in the previous session, is under root of R square plus omega L minus 1 upon C omega whole square. And what is impedance? It is the total resistance which is offered to the flow of the current in the LCR circuit. So from this equation Z will be equal to, now R is the effective resistance of this circuit. So in this case it will be equal to 6 plus 4, which is equal to 10 ohms. So okay, this is an inductor coil which is also having some resistance in its winding, and this 5 millihenry is the self-inductance of this inductor. So the effective resistance of this LCR circuit is equal to 6 plus 4, that is 10 ohms, and so R will be equal to 10 ohms, so this is 10 square plus L is equal to 5 millihenry. So here I will be converting into henry, which is equal to 5 into 10 to the power minus 3. This is the value of L, and omega is 2000 minus 1 divided by C. C is the capacitance of that capacitor, which is 50 microfarad. So this will be equal to 50 into minus 6 into omega, which is equal to 2000. So the value of impedance will be equal to, this is equal to 100 plus this will be equal to 5 into 2000, which is equal to 10,000 divided by 1000 minus this is equal to this 10 to the power minus 6 can be taken in the numerator, and this in the denominator I will be getting 10, 1, 2, 3, 4, 1, 2, 3, 4, and this is whole square. So from here I will be getting 1, 2, 3, 4, 5. So this is equal to, Z is equal to simply 100. This is 10 minus 10, this is equal to 0. So this is equal to under root 100, and this is equal to 10 ohms. So the impedance of this circuit is equal to 10 ohms, and now we have to find the amplitude of the current. So the amplitude of the current, which is denoted by Im, so this is equal to Vm divided by Z. The Vm is what? It is the amplitude of the oscillating potential difference, and so here in this case Vm is equal to 20. So Im will be equal to, this is 20 volts divided by Z. Z is 10. So Im will be equal to 2 ampere. Okay? So the amplitude of the current in this LCR circuit is equal to 2 ampere. So I hope that you have understood the solution of this question. So here the most important thing was to find the impedance of this LCR circuit, and impedance is basically the total opposition or the total resistance which is offered by the elements of this LCR circuit, that is this resistance, this capacitor and this inductor, to the flow of the current in the circuit. So after calculating the value of Z, the amplitude of the current can be calculated by this formula, that is Im is equal to Vm upon Z, where Vm is the amplitude of the oscillating potential difference, and this amplitude, that is Vm, is equal to 20 volts. So I have just substituted this value in this equation as 20, and Z was equal to 10. So the value of the amplitude of the current is equal to 2 ampere. So thank you very much for joining this session, and in the next session I will be coming up with a different type of this circuit, and so till then, have a nice day. Bye.